All right, let's talk about some logarithms. So when we talk about a logarithm, we sometimes abbreviate it as a log. Not this type of log, but this type of log. Essentially what you need to know about a logarithm is that it's basically an inverse of an exponential function. So if our exponential function is this red line here, the inverse, remember, it is reflected over the line of symmetry of y equals x. The logarithm is going to be this inverse here. So the way that we write a logarithm is we would say something like log base a of y equals x, if and only if y equals a to the power of x. And one way that I like to manipulate this is I take a, bring it to the power of x, and set that equal to y. That's how I like to remember it. And another thing to know is that if the log doesn't have a base, so if there's no a written here, whether it's 2 or 1, if there's nothing written there, then we assume that it is base 10. So let's take a look at a few examples where I can turn a logarithmic equation into an exponential equation using my cute little arrow trick. First thing I'm going to do in number 1 is I'm going to have 2 to the power of 3 equal to x. And I know 2 cubed is 8, so x equals 8. And I can check that very easily because I know 2 to the power of 3 will result in 8. So let's look at another one where my x is on the other side. So I'm going to have 3 to the power of x is equal to 81. And I know that 3 to the power of 4 equals 81, so therefore x equals 4. And I can check that again because I know that 3 to the power of 4 equals 81. So let's try this one. 7 to the power of x equals negative 49. Now, I can't think of anything for x that's going to result in a negative number. Not even 7 to the negative exponent will give me a whole negative number. So this can't happen. So another rule to know about logarithms is that this number here, this resultant, has to be greater than 0, because you still couldn't have an x here that would give you 0. So it has to be greater than 0. So now let's work backwards. Let's take an exponential equation and turn it into a logarithm. So knowing what I know of log a of x equals y transforms into a to the y equals x, remember, because of this. Let's just plug in what I know. So this m would become my a, this 4 would become y, and 24 would become my x. So if I plug that in here, I would get log base m, where's my x? 24 is going to equal my y, or 4. And I can always double check that because m to the 4th is going to be equal to 24, which is what I started with. Another thing I can do with a logarithmic function is I can actually find the domain of it. So if I have this example function here, I need to check what the domain is. Now, I'll check on the graph in just a moment, but I can also do it algebraically. So what we saw a couple slides back is that this piece has to be greater than 0. So that's what I'm going to use to help me figure out what my domain is. So I will have x plus 3 greater than 0. I take away 3 from both sides. X has to be greater than negative 3. So when I set this up, x is an element of all real numbers, and x is going to be greater than negative 3. So let's now check that with the graph. So looking at the graph of this function, I noticed that it is a log function, or the inverse of an exponential, and as it approaches negative infinity on the x, it's going to get closer and closer and closer and closer to x equals negative 3, but it has to be greater than that because this cannot be 0. All right, we cannot talk about logarithms without talking about the natural logarithm. So a basic logarithm has a real number base, typically base 10, but it can be any real number. The natural logarithm base has a base of e. So it's like saying log base e of x equals y. But the way that we denote this without having to write log base e every time is we use something called the ln, or the natural logarithm. So there is a button on your calculator that does this beautifully. So the natural logarithm is the inverse of e to the x. Same as how a logarithm is the inverse of an exponential equation, the natural logarithm is just a very specific kind of logarithm. So really the important thing to know is that the natural logarithm is a type of logarithm, and whenever you see e, you should think ln, and vice versa. Now it's time to solve some log equations. So I'm going to use the same trick that I did before. I'm going to have 3 to the power of 2 is equal to 4x minus 7. So 3 to the power of 2 is 9. I'm going to add 7 to both sides. So x is going to be 4. And if I plug that into my calculator to check, I end up with 2 over here. Simple enough. Let's take a look at another example. Let's say I have e to the 2x equals 5. Now, I can't turn e into 5 or 5 into e. So I need to use something to help me cancel this out. I'm actually going to use the natural logarithm, because remember, natural logarithm e, natural logarithm, they go together. So the way that I do this is I'm actually going to apply ln to both sides. It's like if I was going to square both sides, add 5 to both sides, I'm going to apply the natural logarithm to both sides. So that would be an ln here and an ln here. Now let me show you why this works. Saying ln of e to the 2x is like saying log base e of e to the 2x equals something. And remember our rule, so if I have e to some power, that gives me e to the 2x. And because these have the same base, I know that this question mark is just going to be equal to 2x. So when I apply the ln here, it actually cancels out the e, leaving me with only 2x is equal to ln of 5. Now I can't cancel the ln and 5 here because they don't have the same base. They're not going to cancel in the same way that these two e's are. But what I can do is I can manipulate my equation over here, divide both sides by 2, and I have x is going to be equal to ln of 5 over 2. And there's actually an ln button in your calculator, and if I wanted to approximate that, it's going to give me about 0.8047. So either of these things will work. That's going to do it for this video. Thanks for watching.